To meet today's demanding expectations, apps need to be fast, available, and flexible. Designed for developers, Azure Cosmos DB is a stellar distributed database service. It's fully managed, fast, and offers the flexibility to build apps of any size or scale with relational or non-relational data. Let's say you want to build a multi-tenant SaaS application that needs full relational query and ACID compliance with the high performance of distributed data. Azure Cosmos DB for Postgres blends cloud-native performance and the highest level of compatibility with the Postgres ecosystem, plus high regional availability. Or maybe your e-commerce app needs to scale overnight to meet customer traffic spikes. Azure Cosmos DB for NoSQL, MongoDB, and Apache Cassandra delivers the low latency and high availability to satisfy demanding shoppers and keep up with growth. Whatever you're building, Azure Cosmos DB has the speed, scale, and SLA-backed high availability you need to deliver an always-on app that meets evolving standards. The free tier makes it easy to get started, develop, test your applications, or even run small production workloads for free. The app universe awaits. Take off with Azure Cosmos DB.
Hey everybody, welcome back. My name is Jay Gordon, and this is the Azure Cosmos DB Global User Group, where we get together once a month. I try to do it first or second Tuesday of each month, and we talk with members of our community about Azure Cosmos DB. We are working with our partners at the Microsoft Reactor, and I've got one of them right here. It's Alicia. Hi, Alicia. How are you today?
Good. How are you, Jay?
Great. So one of the things that we always do before we actually get into our session is we've got some housekeeping that has to happen. You want to make sure that everybody has the best session possible, and also contributes in the best way possible. So I'm going to bring up your slides and let you kind of go through our code of conduct and other stuff.
Perfect. Thank you. Yeah. Before we begin, there are 2 items that we want to review with you. First, our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We do encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. This session is being recorded and will be available on demand in 24 to 48 hours. And if you've not been on a live stream to YouTube before, here's the event guidelines. If you've not been on a live stream to YouTube before, please know that you must create an account on YouTube in order to access and interact in the chat. You can set up now. And if you have any questions, feel free to reach out to us.
Great. Thank you so much, Alicia. I appreciate that. I know we've got some things to kind of close out with, and I'm going to see you right after we finish our sessions with our session with our guest. So take care. I'll see you in a little while, okay?
Sounds great.
So, like I said, my name is Jay Gordon, and welcome back. I've got a really great guest today. He's going to be talking about change feed in Azure Cosmos DB. We're going to be talking about how applications can be built better because of this service. And to bring in my guest, I've got Harpreet Gill. How are you doing?
Hello, Jay. Good. I'm good. I'm Harpreet Gill.
Great. It's nice to meet you. Thank you for being part of this one. We've got some really amazing subjects to talk about today. I know you've got some stuff to show us. We're going to talk about change feed in Azure Cosmos DB, and just want to make sure everybody is up to speed on what it is. Let's talk about it. The change feed itself, let me make it a little bigger for everybody. Very cool. The change feed is a persistent record of changes to a container in the order they occur. So let's say there's a add to a collection, the change feed is going to get up. If there's a modification to the change feed, or I should say to your container, your change feed will be updating. So then you don't actually have to run queries every single time you want to read that data. And we're going to talk more about that. But first, I want to ask you a little bit about yourself. You're a member of our community. You reached out to me like everyone else can. If you're a member of our community and you'd like to contribute, really all you have to do, fill out this submission form, AKAMS Azure Cosmos DB /user group submission. We encourage people from our community to take part. So you found our group, and you've got a lot to say. Why don't you first tell us a little bit about yourself?
Absolutely. Well, let me start with this. Well, good afternoon to you, but I know there are some folks in good morning time zone, good evening time zone, since we are global. So welcome. I first of all appreciate the opportunity to be here and have this conversation. The way I found out about this group and the community was through Azure DB conference. I was just looking for something to learn a little bit more and maybe take part in. So I went through that process, found the different links, like went through that rabbit hole, but finally figured out where you guys were, and I'm glad I did. And that's how I ended up here. Little bit history about. Oh, we can jump into that later, I guess. Yeah.
Oh no, I just wanted it. Let's just hear a little bit about your role at CMRI and what you're doing there.
Absolutely. So I work at Children's Mercy, Kansas City. So we have a research institute that's aligned with our clinical mission. So we are a hospital to begin with. However, we have a big presence in research community. So what I do, I manage a team, and I'm fortunate to do that. Manage a team of software engineers who are working daily to find solutions to these complicated problems. And as you know, technology plays a immense role no matter in which field you are in. So that's what I do. Our mission for our team is to provide technical solutions to our researchers. That's what we're here for.
Great. So I know you've got a presentation for us, and we're really ready to see it. We'll be here, everybody, for about 50 minutes or so. So you've got plenty of time to go through what it is that you want to show us. As it says in the little banner below me, if you have questions and you're in the chat, please post them there. We will address them as soon as we can. And more than anything, just take in all this information, enjoy it, and remember, you can be part of it. So I want you to tell me now where you're watching the show from in the comments. Go ahead, let me know where you're checking in from. But just to go ahead, let's get into what Harpreet just got to say. I pulled up the screen. Why don't you get started?
All right, thank you, Jay. Well, let me just start with that. I'm checking in from Kansas City. So hopefully you guys are having a great, as I mentioned, morning, evening, or afternoon. So my talk, as Jay alluded to, is about change feed, but it's a little bit more. We will go around. We'll cover the whole story of why we ended up looking at change feed in general. But again, a quick introduction. Again, my name is Harpreet Gill, manager of research software engineering team, and you can find me in all these fancy different places, or you can just shoot me an email or reach out if there's anything. But there are experts at Microsoft who might be more helpful. But if I can help with anything, please use these tools. With that, we'll begin. One thing I always like to do anytime I'm talking to anybody, any community, giving a presentation or a talk, is just setting the expectations straight. That's very important. So, what are we going to talk in this presentation? So, we'll start with the story, a use case, because I feel that helps us combine the whole idea of why we want to talk about this uh, product or service in general. And then that's where we'll start plugging in some missing pieces, and change feed is going to be the main component there. And then we will discuss a little bit more about change feed in general, what it does, and how can you bind events. And in this case, I'm actually not talking about software engineering events. I'm actually talking about just general events. Like, what if you want to do something downstream? How are you going to bind that? So there's immense power in the change feed and the Azure Cosmos DB architecture itself. However, we are going to focus on one use case, but I just want to let you know there are multiple different use cases, and we can chat about them as well. So as I mentioned, use case, I'm going to demonstrate how you do a quick two-way SMS or text messaging sending system. Again, the idea is to keep it simple. Just go over the proof of concept and look at how is it possible. How do you even think about building a system just from a change feed, which can actually increase your interaction with your customers and a lot more different things. And finally, we will talk about a little bit of how would you implement change feed in an actual system, because just to clarify, I'm a big fan of keeping it simple. So this slide deck or this presentation is going to be fairly simple. We will talk about a lot of our overarching or main ideas behind change feed. However, like when you run into actually implementing change feed, what should you keep in mind? So we'll try to touch some of those topics as we go along. All right. So let's just jump into our use case. Before I show you the use case, again, I wanted to keep a couple things in mind, keeping it simple. And of course, for many different reasons, I'm not displaying the actual production system here. However, I am displaying what actual use case was, and like what did we do to figure out what change feed can provide us in this case. Now, going a little bit back, as I mentioned, we work at a research institute. At our core, it is about finding solutions to the problem. We are in a pediatric clinical space, so we are a children's hospital, so which makes uh, our mission even more important in that case. So this was a research protocol, and again, going a little bit, trying to give you a little bit of pointers here so that it makes sense as we go. Research protocols are generally tiered protocols. What I mean by that is you generally start with a pilot study, small study with a small cohort, a small group of participants, some data coming in, but that quickly becomes a huge study once you find enough material in it to do more research. So this is a result of that. So we had a study which had limited funding and they needed a data store. So we built a data store for them, and there were a bunch of collaborators across United States and some global collaborators who were pushing data to this data store. Most of this data was activity related data. So you can think of your Apple Watches, Garmin, Fitbits, those type of devices were talking to us. But in some other case, there was some specific research related data that was being written to this data store. So our researchers were able to see the value in that. And then what they did with that data store in the initial pilot study was they basically built a data engineering and data science platform. Again, very simplistic visual of what there actually is. However, gives you enough idea. So the data comes from data store. You go through your data engineering pipelines. then the data science kicks in, the modeling and prediction models come in, and you eventually show that in a dashboard. So you can imagine this, you are looking at a patient who has, for example, type 1 diabetes, and they wear a glucometer. So that's the device which tracks how much insulin you're getting, and that device is actually talking continuously to a system. So this would be a system like that. And what our researchers can do once they're in a research study and they're looking at some patient with XYZ condition, they can actually predict with this model what's going to happen in the next 24 to 48 hours. Do we need to reach out to the caregivers? Do we need to make sure we have enough space in our clinics to see this patient because it looks like they might visit us? But that's the overarching goal. That's the idea behind the study. But one thing our researchers very quickly realized when they started doing this, it's great. We are collecting data and doing some reports and reaching out to somebody 24 to 48 hours later. But there are some conditions where we should actually interact with them right away. And that's where a need for near real time, I'm being cautious here, it's not a real time intervention, but pretty near real time intervention system that our researchers were interested in. So that threw us, in a loop, and we were trying to figure out how do we build this system. There were some business requirements which needed us to just listen to what's coming into the data store. They wanted to listen and see if an activity data comes in. For example, I'll give you one quick example here. For example, you're wearing your a Fitbit or Garmin device, and we see you walk 10 miles. However, we don't see any heart rate fluctuation. So what's going on? So they want to reach out to the participants right away, because in that case, it's possible either watch is malfunctioning or something is going on which could impact a clinical decision later on in the pipeline. So very important for us to do it near real time. All right, so that's the story. I've set up the whole theme of the story. Now let's jump into the content. We got a brilliant introduction in the beginning about Azure Cosmos DB, so I'm not doing justice to that. However, again, keeping it simple protocol. It's a fully managed NoSQL, and there are a lot of other components you can use, but what we use is mainly NoSQL, and it's a relation database for modern app development. It is very cost effective, which was one of the main reasons we chose it, and it is very easy to scale. That was the other reason we chose it in our initial implementation. It's been, I think, almost 3-4 years ago. Apart from that, it's very well integrated with our Azure services. So we use a bunch of others. So we are an Azure client, if you haven't guessed it already. And it's very easy for us to integrate with a lot of other services down the stream, and hence change feed was a great option for us when we were considering this. Now let's jump into the actual change feed. Jay again talked about it in the beginning. Again, phenomenal introduction to change feed, but now looking more from a software engineering side of things, it is a persistent record of changes. So if anytime your data changes, now in Cosmos DB world, you have containers, which are your main collections where data is being added or deleted. Anytime something happens in those, it is a persistent record. Very important word, persistent. We'll touch on that later on. And again, it happens in a specific order. So if you create a record, update a record, there is a specific order to it. And that's, again, very important for designing systems, especially like ours. Again, now the feed output can actually be distributed across one or more consumers. That was another main reason. And you see on the right, and by the way, most of this material, screenshots, pictures are from learn.microsoft domain. I've put some source at the bottom of the screen. But if you just Google it, it's a great resource for you to get up to speed on things like that. So I give 100% credit to them. So I'm just demonstrating their work. Coming back to our presentation. So again, keeping a few things in mind when you start thinking about change feed. Even though it is order-based process, but the order is guaranteed per partition. So for example, when you change a record in one partition versus other, and then you do multiple changes back to a previous partition, you can guarantee the partition-based record is going to be in a particular order. However, it is possible that different partitions can come or at least notify you at different times. Keeping that in mind, again, very technical implementation, but we will touch on that as well later on. So if you're just listening to the feed at Azure Cosmos DB change feed, right now it gives you inserts and updates. And Deletes are not supported by default. However, there are strategies to use or like make things change a little bit so that you can still accomplish what you're trying to do. And we will talk about those strategies later on as well. And again, if you want to get like one key piece from this presentation is this last point. The change feed is generally do push and pull model. Personally, I think that's a pretty critical understanding of like when you're looking at change feed and how do you want to implement in an actual system. And again, we'll jump into that right away. Now let me go back to my story, and that's why I use this story, because now you can start connecting few dots, and our presentation will start making sense here. So now instead of data store, we have put Azure Cosmos DB because more than 90% of our data was being written or is being written to Azure Cosmos DB. But staying true to the system, when I talked about data store, there are some data sets like flat files that get written outside of Cosmos DB, but they are not very relevant to our workflow. So now you saw we changed Azure Cosmos DB became our data store, and then you see a change feed. Earlier in the initial description that I showed you, there was no connection between data store and this near time real intervention system. Now there is. Change feed is going to be our source of sort of truth, or a source which will tell us when this intervention system should run. All right. Now let's jump into the push model. And I'm actually not talking much about pull model in this situation because there are multiple reasons. A, it's very rarely you'll need a pull model in such situations. It's very expensive. I shouldn't say very expensive comparatively to a push model, hard to maintain and build. However, it might fit some use cases very, very well. So if you're interested, please reach out to the source at the bottom of the screen and read a little bit more about both the models. However, I'm going to talk about push model because that's where most of our systems are, and that's a recommended way for us to consume change feed as well. In a nutshell, what it is, at any time a change event happens, that will be pushed to a compute resource. How do we know this, what resource it is? And we will talk a little bit about how the bindings work in change feed. No need to poll, as I mentioned. If you are somebody like me who has worked in traditional data relational databases, and somebody had to keep an account of what is being added to each row, it is such a time consuming process. Polling, understanding what changed, it's complicated, but again, some cases it might work. And the other piece, which I personally feel is probably the most important piece, is the load balancing and error handling capabilities which are built in. Again, load balancing lets you fan out or expand your resources if you need it. And on the error handling side, there is ability provided already in the SDKs to at least guarantee you one event notice when an event happens, and that's very critical as well. So there are two ways to implement a push model. There's a change feed processor and Azure Functions. I'll quickly go over change feed processors, but we will mostly talk about Azure Functions because they are pretty more intuitive and which work very well with our implementation as well. However, what a change feed processor is, it's an idea, which is implemented in form of SDK, so in form of a library, and is available to you in Cosmos SDK. So the idea here is anytime you have a compute resource which is listening to feed, that resource can sort of create a lease, or at least listen to a specific component, or at least specific partition in your database, and it can pull and it can listen to all the pushes coming from that feed. So that's a basic idea, and we will chat a little bit more about both of these in the next slides. So I don't want to go into too much details, but in a nutshell, it's a process, it's an idea which sort of guarantees you at least one event per change feed event. As I promised, a little bit more into both of these. Again, change feed processor, it's a library, it's a lot more fault tolerant, and at least once delivery is a very critical piece of that. You can listen to feed in different ways, but this is very critical when you're designing a system which needs to listen to anything that's coming in. It definitely gives you a lot more control over change feed, and it uses observer pattern. Going back to our architecture or object-oriented patterns, learning phases, when we learned observer pattern, this is a great implementation of observer pattern. As you know, in observer pattern, there's a resource that's listening or at least observing a specific event, and that's where it gets the whole idea from. Part of, as I mentioned, it's available as a library, so you don't have to write code for it. Just use it. One cool thing in this is, as I mentioned, there are certain lifecycle events in a very, if you're running a system that needs to know exactly who's getting hold of lease for which partition, it can give you some of that components inbuilt. And again, but that gets very much detailed into change feed. If you're implementing a system which needs that much detail, please go through this change feed process in a little bit more detail, and it might be a solution for you. And again, it can be hosted on multiple platforms. Um, if you are not in a place where you cannot use Azure Functions, this is a great solution for you to run it on a VM, run it somewhere else if that's your preferred option. And of course, keep in mind, it is a push model. So you want a long running process which is always listening. You don't want a process to start anytime a new push comes in, because starting and stopping will be very hard. So long running, think of it like a service that's listening all the time. That type of implementation works very well. On the right hand side is what I like personally, and what we tried out when we were investigating Azure Function triggers. So Azure Functions, as not going into much details of Azure Functions, but it's a serverless compute that you can deploy, and right off the bat you have a component that's running on cloud, and you can build in triggers. So these triggers are basically event hooks to a certain event that is happening upstream somewhere. In this case, you can easily combine a Cosmos DB trigger to a function app, and the whole chain will perform absolutely beautifully. Again, as I mentioned, quick and easy. Uses change. Now, this is a cool part. It's actually using Azure Functions are using change feed processor behind the scenes. So what that means, they are guaranteeing that at least once you will be notified for a change feed event. And so that was a cool thing when I was investigating initially, and I found out, okay, so you're getting all the good things of change feed processor, not necessarily the complexity of it. If you don't need it, if you need it, of course, go that route. But if you don't need it, let that complexity be handled by Azure Function triggers, and you just manage your workloads. All right. So as we discussed a little bit about what does actually a change feed binding looks like, if in an Azure Function case, in a nutshell, there are two main components. One is the container which you are monitoring. So, for example, if I'm putting in activity data, I have an activity container on the right. You can see a screenshot. We That's the container I want to monitor. So that's one binding that we will do. And the second binding is the lease container. Now that's something which is required for a trigger, or at least a change feed listener, a compute that is listening to change feed, to have that container. So that's an additional container that you have to you can let the SDK build it for you, or you need one. So keeping in mind that that's one thing that does come into play, and you don't want that container to be messed around much, because it has on the right hand side, I'm showing you one of the leases. So actually there's a record in that lease container up there which is showing you the bindings, which actually there is a particular function app that's running behind the scenes, and this is the actual lease which it has taken over. So it's very critical to keep in mind that this container, you let change feed do its thing. On the left hand side at the bottom, you can see an example of a snapshot how a binding looks like. And again, please excuse if I'm not using a proper format or something like that. This is just for introduction purposes. But you can see there is a function name. There's a function app that's using a Cosmos DB trigger. And once you put a lease container in, it understands you are trying to listen to change feed. I mentioned that because there are different types of Cosmos DB triggers. There are multiple. You can listen to them. You can do some other things. So I want to clarify, this trigger is for change feed. So listening, inbound processing, and that's what enables us to do this. So, everybody likes, I think we've shown enough screens and talked about enough stuff. So let's jump into code here real quickly, because I do want to show you a couple of cool things before we move on. So this is the example of code which I just showed you earlier. So what you're seeing here is, again, right off the back, if you come in and create a new function app, you get the SDK or the tool, actually Visual Studio, tool actually lets you build this from the back. So you don't have to even start off. They'll actually give you a snapshot or predefined code set for it. That's where I started. I just went in and changed all the connections and anything that I need. Of course, not sharing the connection string here, but you will put a connection string in your settings somewhere. That's how it knows which database you're trying to talk to. So that's all. I mean, if you look at it, just how many lines of code is that? Less than 10 lines of code. That's all you needed to do to hook up to a change feed. So you can run change feed locally. So once, if I were to run this function locally, it will create a new lease and it'll just start binding, and all the changes in your database will start coming. So a couple of things to keep in mind here. If you are building a system, as we saw in our initial uh, presentation, or at least in the initial earlier in the presentation, that you can have multiple compute resource listening to same change feed, and this is basically what it's saying. So if you were to build, if you were to run multiple functions, if your workload is so massive that you need more than one function to handle it, you can use this prefix. It'll just keep in mind, it'll just split the leases in a better way, and it'll allow you to expand your, or at least fan out your compute resources. Again, you can read a lot more about how do you fan out or how do you put more compute resources once you go to Microsoft domain. Anyway, so what ends up happening once a Cosmos trigger is fired, process run in the SDK, you end up with an input. Now, input in this case, it's a list of activity. Activity is nothing but the same container items that I showed you earlier. In our case, activity is just Poco, plain old. It's just a record that I'm listening to, and the bindings, when the record comes in, that automatically gets serialized into my record, so I don't have to do any of that stuff either. So serialization, everything is taken care of up the stream. So once I have my activity, in this case, again, just for demonstration purposes, build a very simple logic here. What I want to know in this system is, if I see an activity, in which case this activity is a device activity, and if I'm seeing device reading of 0 or less than 0, which means I'm not getting a reading from my device, I want to reach out to my participants and see, are they wearing their watch? That's a simple use case here. So now, taking a step back, we have talked about how are we going to bind the Azure Cosmos events. This is how we are going to bind. Now let's talk about the other side. How are we going to fire a text message from that event? So I'm going to switch here back to our presentation, and then let's move on to the next piece. We did the demo. All right, so what you saw in that code snippet, now we know something happened in Cosmos. We know the condition where we need to do something. What do we do? And this is where, the possibilities are endless. You can do whatever you want. But in our case, we needed to send a text message to notify our user, hey, it looks like you're not wearing your watch. So what's going on? So we chose Azure Communication Services. That's another service or another great feature provided by Azure team. And easily you can integrate those, as I showed you, with Azure Functions or anything else that you're running in your workflow. So just a quick introduction, what Azure Communication Services are. They're communication services, as the name states. They can handle voice, text, email. So in voice, you can do an actual calls, even like Teams calls. So it goes beyond just, sending a recorded message or something like that. Text based, we are talking about SMS, but you can actually use chat SDK. So you can start up a chat session and do your automated chats, just like you have, some other what do you call chat engines you have. So all that functionality is available. Emails, as you know, is also a supported event. Very, very neatly and nicely integrated with Office 365 and Azure AD. So if you are in that space, takes out a lot of complications about authorization and authentication, who should get text, who should not. Again, makes our lives easier when we are building systems. And again, for somebody who's interested in building a more complicated communication-based system, so if you want to host a certain, for example, chat portal, or you want to host something like StreamYard, you have different SDKs available for you. All right. Now, going back to our story, as I told you, I love to, keep connecting our story, connecting to our purpose, why we are talking about this. So now, one thing now you'll start noticing from our previous um, description of our story, in the lower end of this chart, now you see the near real-time intervention system has a couple of new logos. So earlier there was, some gears trying to depict a compute. Now Azure Function is going to be a compute because we have realized that is going to streamline, really connect easily with our change feed. And then Azure Function is going to push certain business logic down to Azure Communication Services, which will eventually create the intervention system. So now this looks a much cleaner picture of now the understanding is a little bit clear why we chose change feed. But let's learn a little bit more. Um, I want to quickly switch and show you a little bit more about the actual service itself. So here, and again, please excuse me for, again, if you like certain way of coding. This is a very early on proof of concept I did. I made some changes to it, but it works. So if you're interested in leveraging using it, please go for it. But I do want to show you what a communication services looks like. So once you have the package, once you get the Azure Communication package, NuGet package, all it is creating an SMS client in our case and giving it the actual connection string. You can choose to do it differently. I'm just doing with connection string. You can there are other ways which are more secure. Please read about that, and that's the production. If you choose to do that, that's probably a better way to do it. However, it's as simple as getting SMS client, building out the actual message that you want to send out, and tag is just to identify, who is. If you have multiple systems who are using same communication services, you might want to know which system is sending text message. So tag does that. But that's all. Again, less than 10 lines of code. That's all it is. Going back to our initial function, and this is where I'm using the actual service. Again, not a production system. Otherwise, if you probably want to do a dependency injection, some other technique to do this. But this is just, we want to get this demo working. So all it is just calling the service and asking you to send this message to this phone number. In a more production system, you would build in systems where you might go and look at a certain phone number, try to find who that participant is, get information, or look at certain activity data and try to find who that participant is and or who that person is, and then send them a message. In this case, I'm sending myself messages. All right, so that's pretty much the code piece. The only one thing I do want to share with you once before we move on back to our slides. So what happens when you send a message? Right? You send a message, but that's one-way communication, and I promised you a two-way communication. And so this is where the two-way communication comes into picture. So the Azure Communication Services has the ability to set up listening event queue. So what all it is doing is once somebody sends you back a text message, it is able to push that data down to your compute, which is listening to that queue. And this is all it takes, less than 10 lines of code. So what we have here is an event grid trigger. As I mentioned, it's an actual event grid that Azure Communication Services is hosting. And that event grid is going to trigger this function as soon as somebody sends you a text message. So what I'm demonstrating here is, and I'll show you, and I'll try to share it on this screen with my phone, which Jay might not like. It will be pretty small, but that's a proof of concept. But I'll show you a couple of other ways. But once I get a text message and I respond to it, the event will be fired, which will end up here, and I will get another message from the system automatically. So that makes system responsive. And in this situation, this is where in a production system, you have some sort of a decision engine, a natural language processing as well. That's also possible. In our case, it's a decision engine which decides, okay, based on this particular response, I want to, triage this particular situation to be looked at right away, or just say, okay, no worries. So that's where that's what we like to do. We like to build the business logic in. So all the technicalities are abstracted. So all you do, you get the opportunity to build the business logic you want in here. All right, quickly switching back. We did a quick demo. So let me do this. How about this? One thing I do wanted to share with you guys is the actual portal. And what I'm trying to share here is how are we going to make the system run? So we talked about, okay, in theory it'll work, it'll just fine, but how quick and easy it is to run. I want to demonstrate here in a bit. So there are a few components that you need to run this app. You need a function app where your function apps are hosted. The apps I showed you are hosted right here, and I apologize, it's pretty much zoomed out, so I'm trying to find my way into what's the best way to show you guys. Anyway, we can come back to it. So all the apps are hosted here. This is our Cosmos DB, which I showed you guys. And again, this is all done for demo, so there's no main, not sharing anything that's I don't want to share. But here you can see I have different containers. This is a lease container, which we talked about, and that's the activity container. That's where we will push the data, which will trigger the downstream change feed events. And going back to our resource group, again, the storage is required for function apps to run. We are not using it for anything other than that, but just FYI, it's required. So these are just few, and I've added an app insight just for myself. There's, of course, Azure Communication Services that will do the SMS part. One thing I do want to sort of clarify for Azure Communication Services. So I'm using my free account, which comes, some free credits that I get just being part of, since I have an account on Azure. However, as you can understand the complexity and the fraud related to SMS and phone calls, by default, you're not allowed to create a, or acquire a phone number in a subscription that is free. So that's why I built communication services in a subscription that's not free, that my institution pays for. However, one thing I wanted to show you is once you have a communication services, and you want to bind the background, the band two-way communication, this is what you have to do. You have to do an event subscription. Again, not going into too much details of it, but just give you a gist of what it looks like. So once you have communication services ready and you have your function app deployed, which we just talked about, which is a trigger that's listening, you will come in and set up that trigger up here. So I'm just going to give you just a quick, let's do this. And if I were to look at, and this is a very critical piece when you are doing these bindings, depending on what you are interested in, you probably want to listen to that specific event. So if you are interested in listening to an incoming SMS, do an SMS event. If you're listening at delivery reports, which is very critical, do that. But just for demo purposes, do that. And this is where
Hey, this is Jay. I just wanted to give you a time check, and so everybody also knows. We've got about 20 minutes left. And when you get to a good stopping point, we do have a good question for you. So just want to keep you and the rest of our audience up to date on how much time we've got left.
Awesome. Thank you, Jay. I appreciate it. All right. So this is where you actually have different options available. So in our case, if we are choosing Azure Functions as our hook to this event, and once you choose that, you have an ability to select which Azure function you want to. So that's pretty much what it is. So once you have your bindings working, and I want to get out of this, this will look something like this. So in our case, we are already bound, and you can see I've been testing for a while, so you can see some data coming here. I'll explain you what I did here, but anyway, this was a mistake. I got 70 text messages in a few seconds. Anyway, but this is how the whole connectivity, going back to our story, this is how system will be connected. This is how you will be able to listen to two-way messages and get back and try to build a system which can respond back, which started from your change feed. All right, switching back. So it's a great opportunity for me to answer some questions, Jay, if there's something.
Sure. We've got a question here. It is from Cloud DevOps and Friends, our friends CDF, and they ask for change feed processor, can it be hosted in an Azure container app instead of a VM?
I believe so. It's if you're building A change feed processor, it's nothing but just a library that you choose to implement the way it is. So if you are building a compute resource which is able to listen to an inbound change feed, and it is on a platform which can do something like that, 100% it should work. And I believe, and I might be missing some documentation there, but there is documentation which sort of lists out all available Azure resources that you can use. Um, and towards the end, I'll probably dig down that, but it was available on the Microsoft Learn framework. In a nutshell, any compute that can listen to an event and it can respond that, but and can use the library from the SDK should do the job.
Great. We'll see if we have any more questions as we get towards the end of your session. I'm going to give you the next 15 or about next 12 minutes or so for you to go ahead and continue. All right.
Awesome. All right. Thank you. All right. Moving on. So we talked about an implementation. We talked about how it would look like. However, there are some technicalities. There are some challenges when you implement. So again, up till now we wanted to keep things as simple as we can, but it's clear once you build a simple system, which is great, which is what we were built for. um, what do you actually see when you are actually doing an implementation? These are few learnings from our experience, and that's where I will definitely, if there are more questions, please let us know, because this is just from our learnings. So one thing keeping in mind, RU consumption. Even though change feed is absolutely free, there is no cost for consuming change feed. There is a little bit of impact on your RUs when you build it. Of course, you create a new container, that's a lease container that will have its own throughput. So when you're listening to the feed, so there's some RU consumptions to keep in mind, which means if you have a system which is already throttling, so throttling, sometimes what happens in Azure Cosmos space, your request units. So let's say you have your request units, and again making some numbers up here, can listen to 100 requests in a second, and you end up sending 150 requests. It'll throttle 50 of those, and based on what implementation you're using, those will be retried after a certain time. So if you're already noticing that, it's pretty easy. It's 429 errors. If you're seeing those, you might want to consider, look at it, look at your monitored container, and maybe reimagine few things. Change feed can still work, but you might have to reimagine your RU consumption in that space. Deletes, as I promised, yes, deletes right now, at least from the documentation, what I've seen, it's not supported in this format. What you can do is use a soft delete process, which we have done in some of our implementations, where we just don't want to delete the record, but we mark it as deleted and add a new field. And you can just, in your business logic, ignore those fields, or use it if you want to use it as a delete collection. Similarly, there's another, once if you implement something like that, you can leverage time to live. So time to live is another property in Cosmos, Azure Cosmos DB, where you can choose to delete a record for if it meets a specific condition. One thing I do want to mention, and this was something the Azure Cosmos team, I recently read about that, and I've experimented a little bit myself. So if you're building a very large scale system, so for context, our system gets somewhere between 500 to 6,000 database requests. Most of them are creating new collections, and some of them are reads. So I mean, it's still a big system, but I've known about system companies which are doing 1 million records in a minute. So that's a totally different scale. So there is a new, it's in preview right now, but change data capture ability. So what you can do is you can actually consume the feed through an analytics or analytical store, so which are Azure Synapse or Azure Data Factory. So there are a couple of good things here. One is, like, they don't consume extra RUs, because in the bigger scheme of things, you are buying into the analytical store. So that's where the analytical stores are hooked up to your Cosmos feed, and they don't consume the RUs. They just do it through the back channel. I'm no expert in that. Maybe Jay can connect you with somebody who knows exactly how they consume. But they don't impact your RUs and your function or your actual app functioning. So that's pretty cool for a system where you don't want to mess with the existing traffic right now. Other thing is it does capture the leads. So it captures it as an event. So you don't have to worry about implementing strategies to handle that. Um, Here is another great screenshot from the Microsoft Learn platform, which shows you, again, it might be small for some mobile users, but basically what it's showing is once you sync your Cosmos DB with an analytical store with ability to listen to change feed, you can design you can design a flow from that analytical store to do exactly what we did. You can absolutely send a message to whatever you need in that store. So you don't have to build a system like this outside. You can leverage no code to less code abilities there as well. That's an important. So keeping that in mind, the leads might be handled different ways depending on your needs. And this is a great screenshot, and I think Jay referred to that to me when I was talking to him earlier. Absolutely gold mine. So whenever you're looking at, or at least when I was looking at change feed and I had some concerns, how, what, when do I use it? There are different ways. There are different, some scenarios it's a great fit, some scenarios it is not. So thinking through, it's very important. So in this case, I'm going to talk about three different design patterns that you can pretty much, they will work very well with change feed. One is event computing and notifications, which is exactly what we did right now. And we saw that how it went through, or at least we saw how it is possible. And then the stream processing, we talked a little bit about, how can you do an analytical store or something like that, which will actually do a real-time stream for you. And then zero down migration is another cool thing, which in some way we want to leverage in future. Once studies like these wrap up, because they have an expiration date on it, we need to move all that data uh, over somewhere. So right now we're doing a big data push at the end of the study. Maybe it's a great opportunity to just do a zero time migrations while the study is going on. So we already have a backed up solution. When the main study closes, we just give that solution to our researchers for further data analysis. So that's something I'm thinking right now. But anyway, gives you an idea what type of different implementations you can do. Doing a quick check on time here. Okay, we have 5 minutes left. All right.
Yeah, we've got about 5-7 minutes somewhere
Okay.
around there. We don't have new questions, but
Okay.
CDF did want to say thanks for sharing the valuable information and clearing this doubt. And also, Zach, thank you for also saying Azure Web Apps or AKS could be better in lieu of using container instances. Anyway, I'll let you get back into it, and I will pop back in about maybe 5-6 minutes.
Awesome. All right, so I have final thoughts slide, but you know what? I thought I did, like, I kept this sort of in my back pocket. I actually want to do a live demo. I actually want to run it right now and see what happens. Do I get a text message or not? Not a big fan of live demos, but it's fun. If something goes wrong, don't blame me. But since we have 5 minutes, let's just do it. One thing, so since I'm doing a demo, all these functions are already deployed to a function app, but I want to run locally and just feed some data in. So I created a quick function app, and that's available in the GitHub repo that Jay shared with you. So all this function app is doing is just writing two data sets, and you can see one data set which is our condition where the health device is sending a reading of 0. And this is the one which will trigger events. So two things you'll see. We will add two different records, but trigger should only be triggered once. So I should get only message once. So that's the reason I'm doing two. And I'm going to quickly just comment these out, because who doesn't like commenting out stuff while doing a while doing a demo right now. All right, so I don't want to run the other function apps. So I'm going to quickly and this sort of gives you an idea, and I'm going to make sure you probably will be able to see my once it runs. I'll share the actual results with it, but I'm going to give it a second to run here. All right. So as soon as we have our function app running, I'll quickly run the trigger. And apologies for small text. This is the console log. But I just wanted to demonstrate that it's running behind the scenes, so I can take it out now. All right, so function app is running. I'm going to quickly go to Postman and do a quick, I'm going to trigger my function app, and all it is doing is going to write a couple of records. So it's not nothing fancy. But I do want to show once that record is processed and written, all right, it's going, it's doing its thing. I'm going to come back. Okay. All right. So what we can do is we can quickly switch over to our, and you should see a spike eventually because it's not consistent, but I want to make sure the app went through. All right, it did go through. So let's do this. I think it'd be very hard for you to see my screen, but I did get a message. If you don't mind switching. Yes, awesome. Thank you, Jay. Let me see if I can share. So this is the message. We got a message. I apologize again, very small, but I'm going to respond back to my own message saying that, yes, I'm wearing my watch. And this is where the two-way communication will start happening. So that message went through the event services, it bounced off this event subscription, and we should see something pop up here pretty quickly. Again, live demo. So give me, but I did get a message again. If you don't mind me putting it back. Anyway, so it's pretty. So I got a response back from the system. So going back to,
it's not that bad. It's small, but you could get the gist of it.
You can see, at least it works. Anyway, so that's the whole idea. I mean, it's going back to our final thoughts, and I'll wrap up then. But again, I enjoy keeping the live demos in just because when it fails, it's embarrassing. But I think when it works, it's cool. Because I think overall, it was barely 50 lines of code, which built the whole system. Again, it's a proof of concept. I agree 100%. But it's a pretty powerful proof of concept. Just wrapping up our thoughts here. Again, change feed, as the title of the talk is, it can even drive your application, as you saw. And that's just one way to do it. There are hundreds of other ways to leverage change feed and do which actually adds value to your systems. Again, each system is unique. Please consider how much value you get from something like this. I'm a big supporter of it, but if you are in an environment where this is not feasible, there are different strategies to work around, but still using Cosmos DB and Cosmos DB, Azure Cosmos DB change feed is a powerful tool. One key thing to keep in mind, it's not a full operation log. So it is not something that will give you exactly what happened to this particular record. It is possible in that transaction, if you do a bunch of updates, it is possible some of those events, you just always see a final state of that particular transaction. So keeping that in mind, it's not going to impact most of the systems out there, but in some systems can get impacted if you rely on each and every small change. And again, the design pattern slide, again, that's a gold mine. Personally, I think so. Because every system is different. Our system, which is doing 500,000 records every day, might not be a big enough system for a big corporate client. So for you, you might choose a different system. Anyway, with that thought, I'll wrap up.
All right, great. So we've got our final thoughts here. I'm going to remove your presentation, and then I'm going to welcome back Alicia. Hi, Alicia.
Hey.
Great. So we had a really great session, and I want to say, Harpreet, thank you so much. I know I learned a lot. I know our audience really enjoyed this session. We got some interesting back and forth in our comments. Really great job. Thank you so much. And so with that, Alicia, I'm going to bring up your screen. I'm going to let you close us out with your announcement about what's next for the reactor.
Yeah, I'm going to try to wrap up quick because it looks like there's some renovations happening. We are continuing the Launch Your Career series, which we are hosting every month. Is it monthly? Multiple times a month, in which we're hosting various professionals to talk about their career, and just a general very cool series to follow. And if you're interested into more events from the Reactor, feel free to check out our website, Microsoftreactor.com.
Yep. Here's a short link right here, AKAMS/Reactor. Great. Well, I think that that's about it for today. We really appreciate you all watching, and know that we'll be back. We try to do this, like I said, every month. And, I need your help. If you're watching and you think you've got something really interesting, just like Harpreet's session, then please send a proposal to our intake forum. Our friends at the Reactor help us get all this to you. We really appreciate what they do as well. So that being said, let's go ahead. We'll give you all the big wave goodbye. See you all next time. Thank you so much to our guests and our partners from Reactor. Appreciate it, and we'll see you soon. Bye now.
Thank you.